today's kind of explanation video, I think I'm gonna show you explain the rear arms. Well, first of all, I think it's good to understand why. This is awesome. Why we're making arms? Well, the reason why we're making arms is because we made the subframe. Now, the subframe is something that I wanted for a long time, and there was nothing on the market that I liked. Either the standard one, which is very flexible and very easy to corrode. Also, the other one that was on the market, that just, it was just wasn't my thing. Plus geometry stuff, but the geometry, we're not going to talk about geometry here because it's going to take a long time. This is the best geometry you can get because Toyota is not stupid. With the 3rd gen, they've done an absolutely awesome job. And the problem is some people, they actually break that geometry and they claim the car doesn't handle right because they blame the engineers from the Toyota, but that's not the case. Anyways, once the subframe was fabricated, was done, and I was like, you know what we gonna put on now? Because standard arms, you can see the difference, it just looks shit against all nice bits. And also is just, well, they're strong enough, arguably yes, but you wanted something improved. Also, you wanted the look. On the market, there's quite a few options for the arms for the mk3. However, they all are, I think, grey or blue, and this majority could be, say, the look point of view. But I mean, I need something to match this. So obviously, mild steel powder coated is something we step away from the subframe. And it just made sense to make arms too much. Initially, I just want to do it for Steve and for myself, as usual. And then Steve say, well, just make them. I say, well, I'm not going to make them for everyone, because to make them in stainless, you have to design them, again, same with the subframe, differently that you will design a structure that obviously has a mechanical stress with a mild steel or with aluminium, Hence, there are different techniques. You have to know the materials, because people pointed out, it's not good to use a stainless for subframes or for arms. No, it is absolutely fine. You have to change the way you design the structure against the mechanical stress, to say it this way, quite poorly. Because if you know the materials and the properties of the materials and the welding and everything, then you understand how to design it. And it is designed differently than I would design it with in the mild steel. Although you can do it mild steel this way, but it will be excessive probably. Also, I want to design it this way to be stronger than it needs to be. We want no flex, because people now with these cars, they're going for crazy power. They're going for bigger engines and the crack. But also, again, massively, I have to admit, for the looks, I wanted something to match the subframe. And you can see how much of a difference. We have the arms for this, but this is great example to see, what the arms should look like and what the arms actually look like. So that is pretty much the reason. Anyways, when you have these subframes, these adjustments, put them up. I know originally they're down, but we shade the subframe a little bit because the standard one goes down unnecessarily low. And if you want to put a diffuser or something, this 5mm, in my brain, which doesn't make any sense, it was good to remove it or have it higher. So they go up instead of down, because if these are down, they stick out about a few mil down, and it doesn't look right. That's not a mistake. I'll just never say that when you put these, you have to put them out, because for me it's self-explanatory. They stick out, they hide them, you put them here, and the top of this is exactly where the welds are, on the top of this, so it matches exactly that size. See, so that's how you put them on. And yes, please use this as the adjustment for your toe. Do not use the adjustment on the length of the arm, because the length of this arm and this arm are important. The relationship in those lengths is crucial. Okay, If you adjust your toe from here, from the length of this arm, you change that relation. And you may change it differently from the right to the left as well, not just relation between these two. And yeah, that's how you don't mess with the geometry. Yes, you can move the hub away with adjustable arms, but you have to do it with both exactly identical. Please don't do it. You have this adjustment for a reason. Use it. Anyways, yes, you can adjust the geometry to your pleasure, but you really have to know your stuff, and it's not as easy as it looks like. It's complicated. But then if you fuck something up, don't blame the car geometry or the to other engineers, because it's kind of ridiculous. Anyways, that is the reason why we made the arms. So let's have a look how we make them. Everything is very precise, right? This is from point of view of business, this is borderline okay for me to do it, because it's too much work involved, too much machining, too much materials cost for this to actually be all right profit. If I was going to make a business purely out of the subframe and these arms, out of the business within a few days. No chance. We only supply it because of the rest. Even the subframes at the price they are now, they will have to go in prices, because I'm just not willing to make them for that price. It just takes too long. I know people say it's piece of art. I want it to be a piece of art, beautiful engineering and everything and welds, and I put loads of effort in all those TIG welds. There's miles of TIG weld in there, and every single part has to be nice. So it's 2 days welding just for one subframe, plus obviously all the other costs. Anyways, back to us. We made them because we had to. I've done the subframe, I have to make it arm, so I make both. But again, I'm not really that keen on making them as a business. It's not really a viable business. Anyways, so when we start with excuse me, with tubes, right? So this is what we start with. We start with this. These are the small ones. You have two different sizes. The small ones, see, this is how they look like. As little pieces as possible, like a puzzle inside. It holds everything, holds the pipe from inside, holds the pipe all around it, and this fuses to be a one piece. And then you have the bigger size, because I'll show you on the car. There's a traction bar, as I like to call it, which is this one here, and that is smaller fitment. This is the bigger fitment, you see. So this is this one here. That's how they look like again, to pretty much make one piece once you weld them up. This is very, very strong. You're not gonna bend these, you're not gonna break those. Once you make them, then we come and we have to cut the pipes. This is again 316 stainless. This is precision pipe. There's no seal inside. So again, this is very strong, but also very expensive. So these are cut to pieces, and then each end is actually machined. There is a need for machining these ends? No, there isn't. But this is, I wanted this to be a top quality product. So even on the manufacturing processing, there is no cutting corners, and they slide in here. Let me see if you can do it one-handed. It should be, if it's all proper precise, it should just slide in. Yes, and it goes in there. And then obviously you bring it to the sides, nice and flat there, and we welded inside and we welded all around it. Now the other side we're using these rose joints. Now these rose joints, these are heavy duty, high precision rose joints. These are not some cheap, shitty replacement. Stainless body. Some bits have chrome moly insets inside, some not. Don't think these ones have. Very sturdy, very strong, very heavy duty, but also very precise. Now these are resistant to atmospheric elements, so they don't like to rust very easily. So even if you leave them exposed, they should last fairly long. However, we supply them with the boots. Do we have the boots here to show you? Yes. So these boots here, a little bit squished. Now this doesn't look like it will go over there, but it actually goes from there. It's very flexible. They go, I mean, that goes through that. I know it's ridiculous, but it goes. zzw30, and there is a technique with 2 screwdrivers to just slide them on within seconds. So there's a lot of YouTube videos to show how to do it, and I'm gonna do it. Now the second part is obviously we have to fit these rose joints to these precisely. Again, does this has to be machined? No, because once you weld all around it, you're never gonna know if this was machined or just cut it with the bandsaw. But again, I will know. And again, you're paying for something that is, top spec. So yes, you have to know how it's made. Now these, when they come to us, these inserts here, because they obviously screw onto that, they come like this. Now these are almost precise. I have to remove about, you can see here, about nothing, a tenth, tiny bit to make them fit. But when they fit, again, let me see if I can do it. So 100. You see? It fits. You see that was nothing, but when you push it, look at it, it just stops there. This is how much tolerances we run, and this is precision work. It's absolutely not necessary for arms or anything. You can bodge it up, you can really go loose and whatever. However, when you do it, when there is a gap between this and this, when you're gonna weld it, you're gonna pull this to the external, this to the inside. I have OCD with the mechanical stuff. Everything has to be nice and precise. So for me, yes, I spend extra time. Yes, I have them to this size and then remove a 10, sometimes even less, just to make them fit and to make them fit perfectly, because I want everything to be precise. Yes, I'm gonna hide it behind obviously TIG weld. TIG weld is in 2 stages. I fuse the material together first and then add material after. I like that technique. This is just weld all around. And yeah, this is, I don't know, this is as precise as you build the engines, pretty much, all the tolerances and everything. Don't need to be, but this is what these arms are. And obviously these are the traction arms. Then we have these longer ones. These are the camber. Yes, these are the camber arms, and these are your toe arms. You see, all of them are machined. I'm not talking shit here. All of them machined, and I can't let a single arm that hasn't been machined or hasn't been precision fitted. On the camber arms, then you have toe arms, and you have these rod ends, good quality, chunky, very good. And again, they are not stainless but zinc plated. This is all stainless, and everything obviously fits there, but they all have to be still machined. As you see, these ones are being machined. These are ready to be machined, and this is the whole process before I actually sit down and weld these arms. Now, before these arms are actually welded, I have a jig. So what it does, I literally bolt this side of the arm and this side of the arm with misalignment bits, because usually these come already just like one piece, but these being heavy duty ones, bigger than we need, what we do, we have stop it. This misalignment spaces, they reduce the boulder, they're very precision made, from I can't remember what size to the correct size, and then you have more adjustment. They don't need high misalignment this, but they actually, again, these are very precise, so we opted for this. So yeah, and before welding them everything up, goes in a jig, bolt here, bolt there, so every single arm leaves the workshop to the exact length as the original Toyota ones, and that's how you put them on. If you want to change the length, you can, but in order to prevent you from doing this by accident, you can't just lose the bolt and turn them around. If this bolt gets loose, it will rattle on the thread, but it will not change the length, because you can't turn them, because obviously they're fixed. You have to remove one end of it and then turn the whole arm or the whole rose joint. That's how you change the length. But then again, you have to know how to do it and what you're actually doing, be precise about it, because then you can't change the length of this. Like I say, you have to change the length of this and the toe arm together. So the length and the relationship between those arms are tied together. So please do not adjust your toe with the length of the arm, unless you know what you're doing, but that's again is a difficult topic. So all of these arms, all three of them, they have their own jig, precisely weighed up, precisely measured, and they go out with a proper good spec. So that's how the arms fit and how they're produced, why we produce them this way. And yes, they are not cheap, but they're actually not more expensive than the good ones on the market. And I think these are, for many reasons, better than the ones on the market. In my view. Then again, I may be wrong. It doesn't mean that my view has to be exactly the same view as you have. You may want something different. I agree on that. Same on the subframe. You may want something different. I agree with you. However, remember that this subframe is a race spec, as is up to the regulations for racing. Now, when you have regulations, when you do, not doing track days, but proper races, most of them, depending what class you are, states that you can change suspension components, but the attachment points, the pivot points, or whatever, so where the subframe attaches to the chassis, and when your arms attach to the subframe, those points, they have to be exactly the same as original. You can change the subframe, the components, but everything has to be replicated in the standard subframe as the points. Hence, this subframe is actually legal for racing. Now, if you're in an open class, you can probably do whatever you want, so it doesn't apply to you. But before the open class, there are many classes that are under the open class. So in open class, you can still use it because it's great. If it's a class with the regulations, any of those classes, this is completely legal, 100%. So that's another thing. Anyways, this is enough for the arms and subframe explanation, and I'm back welding this stuff up. So I'll see you soon.